Hi everyone, so we'll be looking at laws of indices today, and just before we start taking a look at some of the rules, we'll look at what actually indices means, and we'll look at the singular form, which is index. Okay, so by index we just mean using powers. It just means to use powers. And by powers, we just mean how many of the same number or variable we are multiplying together. Okay. For example, we could have 4 times by 4 times by 4. Okay. In written in indices, okay, using indices would be 4 cubed because we've got 3 4s that we're multiplying together. Okay, so that's your 1, 2, and 3 4s. So that's just with the normal number. Okay, and then if we took some variables like t times t times t times t, that would become t to the power 4. So we don't really say t to the power or t to the index 4. We just say t to the power 4. Okay, but the 4 and the 3 are what we mean by index number. Okay, and I'll just underline the number of t's so we can relate that with our power. And then similarly, we could even have decimal numbers like 0.6 times by 0.6 times by 0.6. Okay, we could have a number of these. Okay, I'll just go on the next line, and this 0.6, we've got how many of them? So we've got 1, 2, 3, 4, and 5. So therefore, it just means that we will be having 0.6 to the power of 5. If we were to represent that using indices, okay? So that's what we mean by the term index, okay, which is just a singular form of indices. So now we'll be looking at some laws, and the first one we'll look at is called multiplication. Okay. And this one just means what happens when we're multiplying variables with powers together, okay, same variables or even numbers with powers, what happens to those powers. So for example, we've got t squared multiplied by t to the power of 5. What will our answer be? Well, what we can do is break it down and think about what do these mean individually. So we've got t squared, which just means t times by t. Then we've got t to the power of 5, which means t times by t times by t times by t, basically multiplied by itself 5 times. Okay, and in between these two, we've also got the times sign, so let's not forget that. Do that with a different color. Okay, so since these are all being multiplied together, what we can do is just count how many of these we've got. Okay, just using basic laws of algebra. So we've got t to the power 1, 2, 3, 4, 5, 6, 7. So it's t to the power of 7. Okay, that's where this power comes from. And therefore it means that t squared times by t to the power 5 is also going to be t to the power of 7 due to this explanation over here. So using this, we can derive our law, first law, which is of multiplying indices together, which is that when we multiply powers, okay, we just add them together. Okay. And this rule, I have to say, an important point is it only works, you can only add them if you've got the same variable, okay? It wouldn't work, for example, if we had t squared times by g to the power 5, it will not equal, you know, tg to the power 7. That just doesn't work, or t to the power 7 and g to the power 7. You can't add these powers because your variables are not the same, okay? So for this rule to work, your variables have got to be the same. Must have same variable, okay, or we call it base number as well. Base number. Okay, so that's the first rule. Okay, so our second rule is division, okay, and we'll take a look at what that means. So for example, we've got m6, we're dividing by m cubed, or it can also be written as m to the power 6 using our division sign, and m cubed. Both of these expressions mean the same thing, but we'll just take a look at the fractional form because that can explain this rule in a better way. So for example, if you've got m to the power of 6, okay, that just means we're multiplying 6 lots of m's together. Okay, so 1, 2, 3, 4, 5 and 6. And then m cubed, okay, just means that our denominator will have 3 lots of m's being multiplied together. And then what we can do is, because we're dividing them, and when we've got fractions as well, we have the understanding that we cancel common factors together, okay? That means, because I've got 3 m's at the bottom and 6 at the top, I can cancel out 3 lots of these. Okay, so 1 pair, second pair, and then my third pair, that can be cancelled together. So that leaves me with just 3 lots of m's. Okay, so m times by m times by m, which in fact is just m to the power of 3, or m cubed. Okay, so this brings us to the rule that when we divide with powers, we subtract them. Okay, so when we divide with powers, again, only applies to same base number or variable. When we divide with powers, we subtract them. Okay, so it just basically means that instead of writing it out like this, we could just do 6 minus 3, that would give us m cubed. Okay, and then now we'll take a look at the third rule, okay, which is to do with brackets. So this means that when we've got a question like m cubed all squared, okay, and this, an important point about the square bit is that it means everything inside your bracket is being squared. Is being squared. Okay, and now we'll just take a look at what does it actually mean numerically, m cubed squared. Okay, so that just means we've got 2 pairs of m cubed being multiplied together. So we've got m cubed times by itself twice. That's what the squared bit means. And when we have something like this and we rewrite it in multiplication, we can apply our first law of multiplication, which was that when you've got same base and you've got powers, you can just simply add your powers together, okay? So that means that you'll be left with m to the power of 6, okay? Because 3 plus 3 gives me an answer of 6. And now that we've looked at this rule and we've actually broken it down, we can actually think about what is the shortcut of doing this, or what's the actual rule. Well, the rule says that in order to get to this bit quickly, instead of writing out like this all the time, because remember we can get big powers, we can just do 3 times by 2, so we can just multiply the powers together. So the rule is that when we have powers inside and outside a bracket, we can simply multiply them together. Okay, for example, here we can see that we've got m cubed to the power of 2. We could have just done 3 times by 2, which would have straight away given us m to the power of 6, okay, instead of rewriting it using multiplication. So we'll take a look at some examples now and actually apply all the rules that we've just studied, okay? So the first example will be x to the power of 6 times by x to the power of 4, which again, using our laws of multiplication, we know we can just add our powers. 6 plus 4, okay, gives us x to the power of 10. So the second example is if we had s6 times by s times by s to the power of 0. Now, with this, we know that if we've just got an s with no power actually stated, it just means s to the power of 1, okay? But here we've got something different. We've got s to the power of 0, okay? And what that actually means is anything to the power of 0 is always equal to 1, okay? So I'll just make a note of that. Anything to the power of 0 is 1, okay? That means that, for example, e.g. s to the power of 0 is going to be 1. 5 to the power of 0, even numbers, if they've got power of 0, they'll equal 1. And things like decimal numbers as well, so 0.7 to the power of 0 will also be 1. So now let's get back to actually answering this question. So we're multiplying 3 pairs of s's together, and we've got these the following powers. So what will happen is, since we know that this just equals 1, okay, we don't have to do anything with this. So it's s6 times by s to the power 1, so 6 plus 1, and then remember we're just multiplying by 1 because of s to the power 0 is just going to be s to the power of 7. Now let's take a look at example 3, which is some division question. So b to the power 7 divided by b cubed, which equals, okay, which means that we'll now be applying our rule of division of indices. So we've got 7 and we've got 3 here, same variable, so we're going to subtract 3 from 7, which is just going to leave us with b to the power 4. Okay, and then example 4, we've got l squared divided by l cubed, okay, and we'll be looking at what happens now that we subtract the following powers. So you can get a negative power as well, okay, like in this case, l to the power of 2 minus 3 will just be negative 1, okay? You can write it as negative 1, or we can write it as 1 over l. Okay, and then we've got example 5, which is q cubed divided by q cubed, okay? And again, according to the laws of division with indices, we're going to subtract the powers, so that just leaves us with q to the power of 0, which remember we previously said that anything to the power of 0, okay, is equal to 1, so the answer is just going to be 1, okay? And then we'll take a look at example 6, which is s to the power of 10 divided by s to the power of 6 times by s to the power of 10. Okay, now you could be having a go at some of these questions yourself if you want to pause the video and then check the answers with me afterwards. So here we're going to use BIDMAS, okay, which suggests that if you've got division and multiplication in the same question, you start from whatever is happening first. Okay, so you're going to solve the division bit first because that's what's taking place first. We're going to go from left to right. So s to the power of 10 divided by s to the power of 6 leaves us with s to the power of 4, because 10 minus 6 is 4. And then we've still got times by s to the power of 10, which just means we're going to be adding our powers now, which gives us s to the power of 14. Okay, and then we've got example 7, which is f to the power 7 squared. That's our brackets question. So in this case, when we've got to be multiplying our powers, so 7 times by 2 gives me f to the power of 14. Okay. Next example is n to the power of -3 squared. Again, we're going to multiply our powers, and this time we've got a negative power, which can occur, okay? So it's just using the case of using your negative number rules with multiplication. So -3 times by 2 gives us -6, okay? So it's n to the power of -6. And then if you've forgotten them, or if you want to revisit the negative number rules, I do have a video for that, which you can go and check out on my channel. Okay, and then the next example is 3r squared all cubed. Okay, now this is a slightly tricky one because it can kind of throw some people off or catch them off guard, because the cubed outside the bracket means that everything inside is being cubed. Okay, that means also the 3 is. So if we write that slightly differently, we'll be able to understand what the question is asking us. So that means that the 3 is being cubed, okay, and it also means that it's being multiplied by r squared, which is also being cubed, okay. And then let's solve them now separately like this. So 3 cubed gives us 27, okay, 3 times 3 times 3, and then r squared all cubed is just 2 times by 3, which gives us 6. So it's 27r to the power of 6. Next example is the following. So we've got 5r12 to the power of 0. Again, a kind of a tricky one because you've got the 0 power again. That means we need to remember what that means. Remember, anything to the power of 0 is going to equal 1. We can write this separately again, like I did at the top, to help us understand what's going on. So it means 5 is being raised to the power of 0, and it's being multiplied by r to the power of 12, all to the power of 0. Okay, so that means 5 to the power of 0 is just 1. R to the power of 12, all raised to the power of 0, is just 12 times 0, which is again just r to the power of 0, which again just gives us 1. Okay, so 1 times 1 is just going to leave us with a 1. Okay, next we're going to look at some exam style questions. The first one being L squared times by L cubed, all divided by L squared. Okay, now the previous examples were slightly more straightforward, okay, and these ones we've got a mixture of different operations and rules that we might need to be considering all in the same question. So let's break it down and let's look at the numerator first and try to simplify that. So we've got L squared multiplied by L cubed, which means we can use our laws of multiplication and add my powers, which gives me 2 plus 3 is 5 divided by L squared. That means because I'm dividing, I can subtract my powers, so that leaves me with L to the power of 5 minus 2, which is just L cubed. Okay, second example, or second exam style question is b to the power of 4 times by b to the power of 4 over a squared times by a to the power of 6. again, let's break it down. So if we look at the numerator and solve that first, and then we can take a look at the denominator. So again, using my laws of multiplication, I can add my powers, which leaves me with b to the power of 8 divided by a squared times by a6. Again, I can add my powers because it's been multiplied, the a's. So 2 plus 6 gives me 8. And finally, I'm going to think about now, can I use my laws of division here and subtract my powers? Well, I've got b to the power of 8 at the top and a to the power of 8 at the bottom. Now, I can't really use my laws of indices with division here because I've got a different base number or a different variable that I'm considering, b and a. So I cannot just subtract the powers. Therefore, I will just leave it as this. Okay, that's as simple as it can be for this question. That's the simplest form. So that's how sometimes they can make it a bit tricky in the exam, or even if you're just doing it in class. And then the next question is f to the power of 4 divided by f to the power of minus 3 times by f to the power of 5. Again, let's break it down. So at the top, we don't really need to simplify anything. It's already just one term. At the bottom, we're multiplying the two f's. So what I can do is add my powers. Minus 3 plus 5, remember, gives me f to the power of positive 2. And now I can use my laws of division to subtract the powers because I've got the same variable. Okay. So that leaves me with 4 minus 2, which is just 2. So it's f squared. That's my final answer. So next exam style question, let's simplify the numerator because we've got some brackets at the top. Now, using my laws of indices, I can multiply the 3 by the minus 2, okay, which gives me b to the power of negative 6 divided by, now I've got just a b on its own. Remember that the invisible power is 1. Sometimes or mostly we don't tend to include the 1 in maths, okay? But if we just have a variable on its own with no power that you can see, we know that it's just the power of 1. So now I can use my laws of indices to add my powers. So 1 plus negative 6 is going to be giving me negative 5, okay, using my negative number addition rules. So I've got b to the power of minus 6 divided by b to the power of minus 5. Again, using my laws of indices, I'm going to subtract the powers. Now here we've got to be very careful in how we're doing it, okay? So it's the top one and we subtract it from the bottom. So it's negative 6 minus 5. So I'm writing it out so that we can see clearly what's going on. I've got two negatives right next to each other, okay, over here. So therefore that turns into a plus sign. So that means I'm actually doing b to the power of negative 6 plus 5. Okay, and that leaves me with b to the power of negative 1, which, remember I said, can also be written as 1 over b to the power of 1, or just 1 over b, okay? Okay, next question. Next question is as follows. So we're going to just be looking at simplifying this, okay? It's just a case of division and looking at our different variables and seeing what we can simplify in here. So I can see that I've got an s at the top. Again, it's just s to the power 1, and it's been divided by s cubed, so it's going to be, we're going to be subtracting 3 from 1, okay? So that leaves me with, so if I'm doing 1 minus 3, I'll be left with negative 2 for s. For t, it's going to be 6 minus 4, which gives me 2. And then for u, it's going to be 4 minus, again, my little 1, which gives me 3, okay? Now, I can leave it as it is, okay, or if I wanted, I could write it in another way because I've got a -2 as the power, so I can write that as a fraction as well, s to the power -2, okay, which would look like t squared times by u cubed over s squared, okay, because remember these three terms are all being multiplied together, therefore I can write it like this as well. Both will give you the same mark, okay, unless in the exam they wanted you to write it in a certain format. You just got to read the question. So that brings us to the end of this video. So there were some exam questions as well to put what we've learned in perspective. If you found today's video helpful at all, make sure you give it a thumbs up, subscribe to my channel for more videos. I upload weekly, and also share it with your friends and family. Thank you for watching.